Hello friends, today we are going to discuss delta modulation technique. So let us start. The contents of this lecture are limitations of PCM, delta modulator transmitter, delta modulator receiver, distortions in delta modulator, as well as conditions to avoid distortions in delta modulation. Let us see the objectives. The first objective is to understand the concept of delta modulation, and second, to discuss errors in the delta modulation. First of all, we'll see what are the limitations of pulse code modulation. The encoding and decoding and quantizing circuitry of this PCM, that is pulse code modulation technique, is complex, and PCM also requires a large bandwidth as compared to other systems. So let us see why PCM is not used for broadcasting. So in radio broadcasting, relatively large SNR is required, that is signal to noise ratio. To get this of SNR, the PCM should be with B is greater than 8, that is number of bits required. So the ratio of transmission bandwidth to the bandwidth, baseband bandwidth. So we can obtain the same performance with FM system with B is equal to 6 and with much simpler transmitter and receiver circuit. So higher bandwidth requirement and complicated circuitry, these are the two disadvantages of PCM, which do not allow us to use it in TV broadcasting applications. Now see why delta modulator. So there are some advantages of delta modulations, like delta modulation transmits only one bit for one sample. Therefore, the signaling rate and the transmission channel bandwidth is small for the delta modulation as compared to the pulse code modulation. Now let us understand what is delta modulation waveform. So we can see here, this is x of t. This wave is x of t, which is a analog signal. U of t, this is approximated signal. On x-axis, we can see the time. On the y-axis, we can see the amplitude. And this waveform, this approximated waveform is represented with binary sequence. So obviously, it will be in terms of ones and zeros. So let us see this. Initially, this analog voltage will be compared against the approximated voltage. If this analog voltage is decreasing, or if it is less than this one, then the step size, that is delta, will be decreased. And then again at the second clock cycle, you can check out this input signal x of t is greater than this u of t, that is approximated signal. So in that case, the step size will be increased. So the step size is fixed in delta modulation, that is delta, it is shown over here. If you see at this point, the analog signal, the x of t is smaller than this u of t at this point. So the delta is reduced here and so on. So x of t is the analog signal and u of t is your approximated signal, which will follow the input signal. T is indicated here, that is a sampling period. So this is what delta modulated waveform. And so the code which we are getting is 0, 1, 1, 1, 1, 1, 1. If the step size decreases, your output will be 0. If step size increases, your output will be 1. So that much information is transmitted in delta modulator. Now let us see the delta modulator transmitter, what it consists of. It consists of 1-bit quantizer and a delay block over here. So input signal x of nts is applied to the summer circuitry into this, and then it is applied to, you are getting the error that is here, because this signal will be compared against the reference signal. So you can see that in delta modulation, the present sample value x of t is compared with the approximate value. Approximate value means x cap of nts. So the sampled input signal x of nts and the approximated signal x cap of nts are compared with each other, and the difference, that is E of NTS or EP of NTS will be generated, and that will be applied to 1-bit quantizer. The output of this 1-bit quantizer, it is again considered as a delta modulator output, that is either 1 or 0, and that is again applied to the accumulator. Accumulator, it consists of delay block and this summer circuitry. So this signal U of NTS is applied to delta delay block, and then you are getting your approximated signal. Let us see how this signal will be generated and how it will be compared. So mathematically, we can represent E of NTS is equal to X of NTS minus X dash of NTS or X cap of NTS. Both are same. You will be getting X of NTS minus U of NTS minus TS. So here, because X dash of NTS equal to U of NTS minus TS, the delay unit output is thus previous values of X of NTS. So this applied to 1-bit quantizer, that quantizes this difference E of NTS into 2-bit signal, that is B of NTS. So let us see what is B of NTS. B of NTS is del of sine E of NTS. Okay, so if E of NTS is positive, then the sine E of NTS is plus 1, otherwise it will be minus 1. So B of NTS will be nothing but plus minus delta, that is plus minus step side. So the input to the delay unit in this transmitter is U of NTS is equal to U of NTS minus TS plus B of NTS. So E of NTS is what actually? It is the prediction error that represents the difference between the present sample X of NTS and its previous approximate value, that is X cap or X dash of NTS. The binary quantity B of NTS, if you see at the output of DM transmitter, it is algebraic sign of error E of NTS. And you can say that the B of NTS is a single bit word transmitted by the delta modulator system. So the accumulator in the delta modulator circuit is initially set to 0, and the accumulator output is given by U of NTS, that is plus minus del. Okay, so in summary, you can say that in delta modulator, sampled input signal is applied to the input of the differentiator or error detector, and then 1-bit quantizer. Now let us see what is the bit rate of delta modulation. Here it is represented with R, and it is equal to number of bits transmitted per second. So what you will be getting, Fs is equal to, Fs into 1, because number of bits transmitted are what? 1. So delta modulation bit rate is Fs. Thus, you can say that the delta modulator bit rate is 1 by n times the bit rate of PCM system. Hence, the channel bandwidth is reduced to great extent as compared to PCM. Let us see another method of delta modulator or delta modulator transmitter. Here you can see X of t is the analog input signal and X dash of t is the quantized or approximated version of X of t. Both these signals, X of t and X dash of t, are applied to the comparator. The comparator output goes high if X of t is greater than X dash of t, and it goes low if X of t is less than X dash of t. Thus, the comparator output is either 1 or 0. Now, next block is sample and hold block. Here, it will hold this level. Either this level will be 1 or 0, that it will hold, and it will give you output. For the entire clock cycle, it will hold the signal. The output of the sample and hold circuit is transmitted as the output of the delta modulator. Here you can get it. Now, this signal, it is applied to up-down counter in the feedback loop. So the transmitted signal, it is used to decide the mode of operation of an up-down counter. The counter output increments by 1 if SO of t is 1. Otherwise, it will decrement by 1. The counter output is again converted into analog signal with the help of D2A converter, and it is again applied to the comparator. So this is what DM transmitter. Now let us see about DM receiver. It is very simple one. The DM signal is passed through the accumulator to provide the staircase approximation in manner similar to that which is used at the transmitter side. And the accumulator output, it is then applied to the low pass filter to produce the original signal. We do have an alternative method for this, which consists of up-down counter, D to A converter, low-pass filter, and synchronized clock generator. So you can compare it with the transmitter block. You will find that it is identical to the chain of the blocks which was used in the to produce the x dash of t, that is approximated signal. Here, the original modulating signal can be recovered by passing through all these blocks. So here, 1-bit code word for the output it will generate. Hence, it doesn't need to have framing, and the design of this circuitry is also simple if you consider the transmitter as well as receiver. The applications are, it can be used in digital voice storage. Then it can be used for some type of digital communications also. Now let us have a look on the distortions which are present in delta modulation. That is one, quantization noise, and another, you can see that, or you can find out the two quantization errors here, the slope overload distortion as well as granular noise. So this is what slope overload distortion, and this is granular noise. So the thing is that whenever we are comparing x of t, this x of t with the approximated signal, here we can see if the x of t is initially very high, or the slope of this x of t is very high initially, or if it is much higher than of your approximated signal over a long duration, then x dash of t, this x dash of t will not be able to follow this x of t, and so this slope overload distortion will be generated. One of the way to reduce this SOD is to increase the step size. But we can see another distortion, that is granular noise. If you try to increase the step size, this granular noise will get increased. Granular noise is what basically here, even though your x of t is constant here, approximated signal is hunting above and below for the x of t. So this is what granular noise. So there are two things, that delta should be small if you want to reduce granular noise, and if you want to reduce SOD, delta should be high. That is, step size should be high. But in delta modulation, it is not possible to have variable delta or variable step size. Now let us see in detail what is SOD. We have seen slope overload distortion. When the analog signal has high rate of amplitude change, the encoder can produce a distorted output results. Granular noise, it occurs when analog input has a relatively constant amplitude. In the figure also we have seen. So as in whole, we can say that slope overload distortion, it occurs when step size is too small, whereas granular noise, it occurs whenever step size is too large. In another point also, we can see that SOD, that is slope overload distortion, here the approximation signal falls behind the message, and in granular noise, the staircase approximated signal hunts above and below. So let us see some advantages and disadvantages of delta modulation. Advantages are, it is 1-bit quantizer, it is very easy to design. Then disadvantages are, obviously it includes two distortions, slope overload distortion as well as granular noise. Now let us see the condition to avoid this slope overload distortion. Here slope of x of t is dx of t dt. That is equal to minus a omega m sine omega mt. If you consider this as a x of t, then you can find out slope of this signal. The maximum value of the slope of x of t is what? Minus a omega m, because the amplitude is this much. The slope of the staircase approximated signal is x dash of t is equal to delta divided by ts. So the condition to avoid the slope overload distortion, you can find out. So magnitude of the slope of x of t is less than or equal to del divided by ts. So we can put the value as it is magnitude. You can consider a omega m. It is less than or equal to delta divided by ts. So the amplitude of your signal should be less than delta divided by omega m ts. So this is what the condition to avoid slope overload distortion. In terms of frequency also, you can write this. Signal to quantization noise ratio is SNR. It is represented with the formula 3 divided by 8 pi square FM square FM TS cube. Whereas FM, this is different one. This is cutoff frequency of low pass filter in the delta modulator receiver. Let us see the example. Determine the output SNR of a linear delta modulation system for 2 kilohertz sinusoidal input sampled at 64 kilohertz. SOD is not present and the post reconstruction filter has the bandwidth of 4 kilohertz. See how to find out this. Just use the formula for the SNR 3 into F cube divided by 8 pi square FM square FM. So all the values are given here in the example. Fs is equal to 64 kilohertz, FM is equal to 2 kilohertz, and FM capital M is equal to 4 kilohertz bandwidth of your low pass filter. Yes, just put all these value into formula, then you can see that your answer will be 622.51. You can generate, you can convert it into decibels, that is 27.94 dB. So in this lecture, we have seen the limitations of PCM, then the delta modulation transmitter, receiver, then the distortions which are present in the delta modulator, as well as how to avoid, means what is the condition to avoid this delta modulation. Thank you.